So everyone should be on page 120, lesson 24 homework. If you are at the Zoom right now, you do not need to send these pages to me. But if you are not at the Zoom and you're watching this on your own or you're working on your own today, I do need you to submit these papers to me for your attendance for today.
Ms. Shevchik,
Yep,
this is Tegan. I found an at-home charger for now I can use.
I saw your message. Thank you very much.
Ms. Shevchik,
Yep,
what page is it?
120.
You need gum, Nanny.
Please,
320?
120. Carissa, are you going to be in class today? It looks like, is your camera or is your computer working okay? I see two of your names. I'm not sure what's happening there. Orlando, mute yourself, please. Duran, are you there? I see your name, but I don't see you.
It's probably mostly my fault because he doesn't know any other way. I've never.
Brian, you need to mute yourself. All I can hear is the TV on at your house.
I always felt that.
Or someone else is muted. It keeps telling me Brian. There we go. Okay, Duran and Carissa. Any luck with you guys? You're the only two I haven't heard from that I see on the screen. All right, we're going to go ahead and get started. So we're going to start today by doing a couple warm-up problems. We're going to do number 1, A, B, and C together. And then we're going to split up into some groups to do some small group work with the other things. So before we get started, does anyone have any questions? Okay, I'm going to share my screen so you can see my book. Okay, so we're not really going to worry about this 1 minute. We're just going to see how many multiples, if we can just generate a list. So the very first question says, write the multiples of 5 starting from 75. So I'm going to write the number 75 down first. Reese, what does that mean if we're going to be writing down multiples?
It means like we're going to be counting on fives.
We're going to count 5 fives. Good. So for this question, Reese, we're going to start at 75. And can you just don't talk faster than I can write. Just give me some multiples starting with 75 of 5.
Okay. 80, 85, 90, 95,
Alexis.
100, 105.
Very good. We'll stop right there.
Where are
Nice
you?
job. So just counting by 5s. And when I think of multiples, I always think of the phrase count by numbers. That's how I remember the difference between factors and multiples. Okay, Hunter, help me with writing multiples of 4, starting with 40. Unmute yourself, Hunter. All right, let's have Brian try. Hey, hi, Duran. Can you hear me? Duran, can you hear me? Brian, can you hear me? Miss Anchor, can you hear me?
I can hear you.
Okay, no one's answering me. Okay, Brian, unmute yourself. If we are doing multiples of 4, starting with 40, what comes after 40?
44,
And then what?
48,
Good. And then?
52,
Very good. Another one?
56,
Give me one more.
60.
Nice job. Brian, how did you make that list? How were you so quick? That was very good.
Well, every when it was, I know that when you're counting by fours, I know in the ones place, it's always a 4, 8, 2, and then 6.
Oh, so that you found a pattern. Very good. I know while Brian was doing that, while he was saying, the way I was checking his work was I was counting up 4 every time he would give me a number to make sure his number matched mine. Okay, let's have Nolan. Go ahead and read letter C.
Write the multiplication multiples of 6 starting from 24.
Okay, so I'm going to start with 24. Nolan, what comes after 24?
30.
Okay, now I'm going to stop you here for 1 minute because I know you're pretty good with your facts. So Nolan, we're going to do this one just a different way. So Nolan, 6 times what equals 24?
4.
Okay, so then we're going to try using some factors for this one. Every single time we're going to multiply 6 by something. So this gives us 6 times 4. What's 6 times 5?
30.
6 times 6?
36.
6 times 7?
42.
6 times 8?
48.
6 times 9?
54.
6 times 10?
60.
6 times 11?
66.
And do you know 6 times 12? It's a big one.
No.
Now, I know a way you can get it, Nolan. Start at 66 now and just count up 6 more and tell me what you get.
72.
Very good. Nice job. Cooper, why don't you focus on what's happening on here instead of the chat? I'm not really sure how this is supposed to be set so only I see it. So I'm gonna fix that. Can chat with host only. All right, we're focusing too much on this chat and not on the lesson. Hi, Corday. I didn't see you sneak in. How are you? Good? All right. Duran, can you hear me now? I can see your mouth moving, but I don't have hear any volume. Give me a thumbs up if you can hear me. Do you have your student workbook at home with you, Duran? How about a piece of paper that you can be writing this down on? Do you have a piece of paper somewhere? Okay.
And this is Chef.
Hello.
What are we?
Remember, Tyler, 1 o'clock is ours. Every time we have a math Zoom, it's 1 o'clock. Okay, you're 12 minutes late. We already have all of our warm up finished. Okay, so now we're going to move on to number 2. Maria, go ahead and read number 2. Caliana, if you're coming to class, please turn your camera on. Go ahead, honey.
Numbers that have 30 as a multiple.
Okay, do you know what this question means? Do you remember what to do here?
It's I forget. I knew it, but then I forgot it.
Okay, so we want to see if 30 is a multiple. So we're going to look at everything between 1 and 30 to see if we count by that number, if we'll eventually land on 30. So we know that 1 is a multiple of any number. So now we're going to go through this list. And actually, you can stop at half of 30. So Maria, do you know what half of 30 is?
15.
So you're going to help me with a couple of these, and then I'm going to have some other people join in. But we're going to go through the numbers 1 through 15 and see if we can count by that number and land on 30, or we can also think if that number times something would give us 30. So let's start with 2. If you count by 2s, will you eventually land on 30?
Yeah.
Show me. Go ahead and do it.
2 times 15.
Okay, so you know the factor. Now I want you to count by twos for me.
2, 4, 6, 8, 10, 12, 14, 16. Oh,
You're good. Keep going.
6,
Mhm,
16, 18, 20, 22, 24, 26, 28, 30.
Very good. So you did both ways for us. You showed us how you can count by twos and land on 30, and you know that 2 times 15 is 30. Good job. Okay, let's see. Izzy, 3. If you count by threes, will you eventually land on 30?
I don't think.
Go ahead and try it.
3, 6, 9, 12, 15,
Hmm
18, 21,
Yep, keep going. You're getting close.
24,
Mhm.
27, 30.
Bingo. So, Izzy, you could also think, does 3 times anything give me 30? Can you think of a fact 3 times something equals 30?
No, I don't know. A lot. My three's that good.
Come on, you know this one. Think of your 10.
Oh, 10.
There you go. Yep, 3 times 10 gives you what?
30.
So that means while you were counting by threes, if you were holding your fingers up, your 10th finger would have been 30 because it's the 10th place in that pattern.
Mhm.
Okay, Finn, how about 4? So you can think, count by fours. Do you ever land on 30? Or you can think, does 4 times anything give me 30?
4, 8, 12, 16, 20, 24, 28, 32.
You passed it right up. Now, Finn, what about fives? If you count by fives, do you ever land on 30?
5 times 6.
Very good. So it would have been your 6th place. So 5, 10, 15, 20, 25, 30. There you go. There's your proof. It's your 6th number in that sequence. So now let's think of your sixes. Isla, does 6 times anything give you 30?
Yeah,
6 times what, honey?
5. It's
Okay.
the round back to 5 times 6.
Very good. Great job. Okay, Riley, what about 7? If you count by sevens, will you ever land on 30?
I don't think so.
No, because 7 times 3 is 21. 7 times 4 is 28. 7 times 5 is 35. So you pass it right up. What about your 8s? Does 8 times anything equal 30?
Um, 8
What's it-
times 3 is 20. 8 times 3 is 24.
What's 8 times 4?
And then 32.
All right, you passed it up. What about 9? Does 9 times anything equal 30?
Nine times 3 equals 27.
What's 9 times 4?
And then 36.
All right, so that doesn't work. What about 10?
10 times 3.
So 10 does work. All right, Cooper, how about 11? Does 11 times anything give you 30?
No.
12? Cooper, 12?
I don't think so.
What's 12 times 1?
12,
12 times 2?
24,
12 times 3?
38.
36. So, did we ever land on 30?
No.
How about 13?
No.
14?
Mm, no.
How about 15?
No.
Think again. What's 15 plus 15?
Oh, 30.
There you go. So 15 is a multiple. So that's how, if you make a list, you know you can stop when you're halfway through whatever number you're using. So we went through all the numbers 1 through 15, and we either counted by that number to see if we ended on 30 or we multiplied by. For all of those people who keep turning your cameras off and on, unless you're using the restroom, that's the only reason your camera should be off, or else you can excuse yourself and work on this at another time. But I'm not going to play police officer with the cameras. Okay, so we're going to move on now, and we're going to get into some groups, and we're going to do number 3. So when you're going to do A, B, and C with your small group, when you're in your group, you're going to answer both of these questions. Is 12 a multiple of 3? Is 3 a factor of 12? And then off to the side, you're going to write your proof as to why you think the answer is yes or no. I know there's not a spot for that, but we did that yesterday, and it was nice to see that proof, okay? So do you have any questions about what you're doing with your group? Okay, so I know we have Miss Anchor here, and Miss Jameson, and Miss Gabine. The hard thing is, I don't think I can, well, maybe I can, assign an adult to each group. I'll try. Okay, so we're going to do some breakout rooms. We're going to have 10 different groups. All right. 1, 2. Miss Jameson, you're going to be in group 1.
Okay.
Group 2. There's Miss Anchor. Can't find you, Miss Anchor. Unless you gone? We'll do 1,
No, I'm here.
4, 5, 6. All right, we'll see what happens. Go me, 2, 3.
It might be under my first name.
Oh, I see you. All right, give me about 30 more seconds. Everyone will have a group. And rooms are open. Andrew, are you there? Tyler, go to your breakout room.
Three times 4 equals 12.
Oh yeah. Yeah. What about that problem?
And then, yeah. Is 3 a factor of 12? Yes, because one.
Okay. Carson, could you do number 2?
Is 48 or more?
We're writing down our last problem right now. We're done now.
So what did you guys put for your proof for letter A?
Um, 3 times 4 equals 12
Good. How about for letter B?
for letter B.
Is 48 a factor of 8?
Yes.
Okay, so Nina, what's your proof? How do you know that 48 is a factor of 8?
I know this because you can multiply. You can divide 48. Divide 48. But you can do 48 divided by 8 and get a whole number.
Which is what? What's the whole number?
The whole number is the whole number is
8 times what equals 48?
it's it's 6.
Good. So you would have either 48 divided by 8 equals 6, or you could put 8 times 6 equals 48. Corday, where are you? All right, Corday. So for this last one, what do you have for is 6 a factor of 56?
Yes.
6 times what equals 56? Do you have a calculator handy?
No.
Okay, I'm going to hold this up to, what should I put in my calculator to check?
6 divided.
Start with the big number.
56 divided by 6.
Okay, I'm going to hold it up for you to see what the answer is. So no, because 6 times nothing, 6 times no number equals 56. So, or you could put 56 divided by 6 is 9.333. Okay, if you don't have your book, Corday, just write this on a piece of paper, so then you won't have to do it tomorrow when you come to school, okay? We'll just staple it right in your book. Julian, why aren't you in your group? Unmute yourself. Why aren't you in your group? You don't have any volume. If you're going to come to class, you have to stay on. You can't be getting on and off. Where's your paper at? Okay, you have your pencil. Okay, once everyone gets back, we're going to go ahead and check these. Trace, you're going to do letter A. Hunter, you're going to do B. And Nina, you're going to do C. Once everyone gets back, give everyone a minute. Julian, sit up, please.
They're not randomly just
What do you need, Brian?
out to do this. It just depends. I don't know.
Brian, do you have a question? I
But I mean,
popped up that you raised your hand.
No.
Okay, Trace, go ahead. Letter A. Is 12 a multiple of 3?
Yes.
Is-
Because
Hold on one second.
4 times.
Let's do the whole row first. Is 3 a factor of 12?
Yes.
And then what? Go ahead. What was your proof? Why was it?
Because 3 times 4 equals 12.
Very good. Okay, letter B. Is 48 a multiple of 8?
Yes.
Is 48 a factor of 8?
No.
And why do you think one is, one can't be yes and then one be no? So let's try, Hunter. I want you to count by 8s for me. What's 8 times 1?
8,
8 times 2.
16,
8 times 3.
24,
8 times 4.
32,
8 times 5.
40,
8 times 6.
48.
Okay, so it was the 6th space in your pattern and your list that made this a yes. And then you just told me 8 times what equals 48?
6. What?
So is
Yeah, that
you're
one's-
right. You're right.
Yeah.
I read this wrong, Hunter. Okay, so that is no. Why is the answer no?
Because you can't multiply anything times 48 to equal 8.
Great job. I was not reading carefully. So we're going to put 48 times equals 8, and we're going to put nothing goes in this spot, because you cannot multiply unless we get into decimals, and we're not into that. 48, this number is big already. You can't multiply it by anything and come out with the number 8. Good job, Hunter. I got to write down, you need a badge for today for reading carefully. I was reading it, is 8 a factor of 48? And that was wrong. I got tricked on that one. Anyone else get tricked?
No.
No, you guys are good.
Everybody says no. That's not nice.
Good job.
Somebody.
You guys are on the ball.
Can I do the next one?
I think, was it Nina that was doing letter C? Go ahead, honey. Is 56 a multiple of 6?
Yes.
So if you count by 6s, do you eventually land on 56?
Yes.
Did you do that? Did you try that?
What was the question?
Is 56, so if you count by 6s, will you eventually land on 56? So that would mean that 6 times something would give you 56.
No.
No, because you would not land on 56. So then remember, we did this one. This is one I helped you guys with. Is 6 a factor of 56? So that means 6 times what equals 56?
No.
So, okay, so this is no, but why is it no?
Because six, six times six can't multiply and equal 56.
Right. If you go through your list of 6 facts, nothing ever equals 56. Did anyone type this one in the calculator and use division to solve to prove this one? Any groups? Sunny, what happened when you guys put it in the calculator?
It was a decimal.
Do you remember what it was?
Yeah. 9.33333333.
It should look like that. So you do not get a whole number. So there's some more proof that the answer would be no. Good job on that, B Hunter. I still-
3, 3, 3, 3.
Whoever's talking, please mute yourself unless you have a question. Okay, this number 4 is really a thinking question. I want to see your faces for this one. Okay, so this one is a doozy. It asks us, can a prime number be a multiple of any other number except itself? Explain why or why not. So first, who remembers what a prime number is? Remember that anchor chart where we had PRIME and we wrote 1 and me. What's a prime number? Caliana, what's a prime number? Jack, do you remember?
A number that has like 2 or more factors in to make the number.
That's a composite number. Remember, prime is
It's 2 or
one
less.
and me. 1 and me. Try again, Jack.
Like, I think it was like more than 4.
No, help him out, Cooper.
Prime number has only 2 factors.
What are those 2 factors? Always.
1 in the product.
Very good. 1 in itself. So prime, Jack, only has 1 and the number we're talking about. Composite has more than 2. Okay, so first, let's pick a prime number. Who remembers? Give me an example of a prime number. Jack, why don't you try that one again? Give me an example of a prime number. I'm going to put 1
7.
in itself here. What, honey?
7.
Okay. So, Jack, what are the factors of 7?
1 and 7.
Okay. Tegan, can you give me another prime number?
3.
What are the factors of 3?
1 and 3.
Okay, so now let's just use those 2 to help us kind of drive our thinking here. So these each are prime numbers. So can this 7 be a multiple of any other number except itself? Why or why not? What do you think? Anyone have any thoughts? Miss Anchor and Miss Gabine and myself sat and thought about this one for a while last night. Tegan, what are your thoughts?
It can't be divided into a whole number unless it's a decimal, which isn't a whole number.
Okay, so was your answer yes or no?
No. I mean, no, it can't be a multiple of any other number.
Okay, any other ideas? Anyone else think it's no? Did I see? Oh, I thought I saw a hand.
Ben has his hand up for no.
Who is
I'm
that?
confused.
Who, Miss Anchor?
Finn.
Ben, what are you thinking?
I'm thinking that because it's usually like 7, it can't multiply Like you can't do 2 times anything, 3 times anything, 4 times. It can only do by itself. So it's the opposite of what it says.
Okay, what about you? Chase, just listen and listen to the responses. Colin, go ahead. That was a very good observation, Finn.
The answer is definitely no, because when you skip count, you're using repeated addition, and that's exactly what multiplication is. So when you skip count, and it's a prime number in multiplication, then when you skip count, nothing else will do it because nothing can be multiplied to
Good. That's
answer
a
it.
good combination of Colin and Finn, and Tegan kind of kicked us off. That was all really good thinking about how nothing else can be multiplied to get these numbers other than 1 and 7. So other than itself, since it's prime, that's the only number you can count by to get to that number. This one's a really tough one. I'm not going to be testing you on anything like that. That's just to kind of get you thinking. Elijah, did you have something to add?
I think it's yes. Can I go now?
Sure. Well, I mean, can you leave or can you explain?
No, I mean, like, can I say my reason now?
Sure.
Think it's yes because it's not asking, can it be multiplied by any number, like to get that prime number? It's asking, can it just be multiplied at all by any number except itself? And 7 and 3 can both be multiplied by almost every other number, or they can be multiplied by every other number.
That would make it a factor if it's
Yeah,
multiplied
factor,
by
not a
every
multiple.
number. What about, I have a question when you're all done.
With number 4, or you mean when we get finished at the
Yeah,
very?
with number 4, what do you do with the number 1? Is that?
I think that doesn't, because 1 is neither
neither prime.
It's neither 1 and 0 are special. They're neither prime or composite. So I just wrote those just so we could show that they're prime numbers, but we're really just focusing on the actual prime number.
Okay.
So yes, the answer is no, because you cannot multiply anything else to get to that number. You can't count by any other numbers. Start with 3, end with 3. Start with 7, end with 7. Okay, now we're going to move on to the back. This one's going to be similar to what we did yesterday. I like this one. It was like a puzzle, but we don't have to use different colors today. So I'm going to zoom in on my chart so you guys can see it. And I'll read what we need to do. So we're going to get some new people in here that I haven't heard from today. Let's start with Mr. Pollard. Unmute yourself. Orlando. You're up, buddy.
Is it 121?
Yep.
Okay. I thought it was.
Orlando, can you unmute yourself? Talk. Let me hear you. What's your favorite new math game?
Hi.
Hi. What's your favorite new math game that you won the other day? Do you remember what it's called?
Kahoot.
Yeah, there you go. All right. Okay, Orlando. We're going to underline the multiples of 6. We're going to start with that. So I'll start you off. We're going to underline 6. What comes next?
12.
Yep.
18.
Yep. And if you're stuck, you can always count. 1, 2, 3, 4, 5, 6.
24.
Yep.
30.
Yep.
36.
Yes.
1, 2, 3, 1,
2, 3, 4, 5, 42,
Yep, keep on going.
48.
Uh-huh.
1, 2, 3, 4, 5, 6, 54. 1, 2, 3, 60.
Yep.
66.
Yep.
1, 2, 3, 4, 5, 72.
Yep.
78.
Very good.
1, 2, 3, 4, 5, 6, 84.
Yep.
1, 2, 90. 96.
Very good. Okay, let's have Carissa. You're going to be next. You're going to help me with this part of the question. When a number is a multiple of 6, and that's everything that we have underlined here, what are the possible values for the ones digit? So you're going to look at all these numbers. What do you see in the ones place? Start at the top and work your way down. You're muted. You're still muted.
Two.
What's in the ones place here?
Six.
What's in the ones place here?
11.
No. You have a 1 and a 2.
12.
That's the whole number. You need to look at the place value. We have a tens place and a ones place. What's the number and what's the digit in the ones place?
2.
What about here?
8.
And here?
4.
And here?
0.
And here?
6.
Okay, so then we start repeating. So on your list, you should have 6, 2, 8, 4, 0. What do you notice about all of those numbers, Carissa? They're all what?
Repeating.
No, nothing's repeating here. They'll start to repeat in your chart, but 6, 2, 8, 4, and 0 are all what types of numbers? Riley, do you know?
Even
Good, they're all even. Very good. Okay, Sarah, go ahead and unmute yourself. You're going to help me with B. We're going to draw a square around all the multiples of 4. So we're going to start with 4, and then you're going to go through this whole list. What comes after 4?
8.
Right, make sure you talk nice and loud.
8.
What comes after 8?
7.
I can't hear you. What was that?
12. Then 16. Then 20. Then 24. Then
What was that?
28. Then 32. Then 36. Then 40. Then 44. Then 48. Then 52. Then 56. Then 60. Then 64. Then 68. Then 72.
then 76, then 80, then 84, then 88, and then 92, 96, and 100.
Very good. Okay, Chase, I want you to look at the multiples of 4 that have an odd number in the tens place. So now let's look for an odd number in the tens place.
12.
That has a square around. Can you pick out any?
12.
Okay. So we need to, what value do they have in the ones place? So what
2.
does okay, so we have a 2. Give me another one that has an odd tens place.
36.
Let's go in order. What comes after 12?
16.
What's in the ones place?
6.
Okay. After 16, where do you see another odd tens place?
32.
What's in the ones place there?
2.
Okay, your next one.
36.
What's in the ones place there?
6.
After 36, where do you see your next odd tens place?
52.
What's in the ones?
2.
Next,
56.
ones place.
6.
All right, we'll stop there. So what values do they have in the ones place? What were the repeating digits, Chase?
6 and 2.
Very good. I'm just going to put a box around 2. So it's kind of neat. Every single odd tens place has a 2 or a 6 as the value of the ones place. A 2 or a 6. All right, Colin, you ready for letter C? Okay, Colin, look at the multiples of 4, and we already have a square around those. But this time, we're going to look at the ones that have an even number in the tens place. So once we find an even number, we're going to write what values do they have in the ones place. So look at our squares. Find me, we're going to start at the top and work our way down. What's the first number that has an even number in the tens place?
20.
What's in the ones place?
0.
Okay, our next even tens place.
24.
And what's in the ones?
4.
Next.
28.
What's in the ones?
8.
Next.
44.
Whoop, there's something before 44.
40.
What's in the ones?
0.
And then 44, what was in the ones?
4.
See any others?
48.
And what's in the ones?
8.
All right, we're going to stop there. I'm going to move this up. So we went through 2 whole different rows of numbers in the with even digits in the tens place. We had what pattern, Colin? What pattern did we see?
0, 4, 8, 0, 4, 8.
The question asks, do you think this pattern would continue with multiples of 4 that are larger than 100? What do you think?
Kind of no, but kind of yes. It would continue if it's an even in the tens, but not if it's not an even in the tens.
Okay, so let's just focus on right now if it is even in the tens, since that's what the question was asking.
Yes, it would continue on past 100.
Okay, why do you think that? Carissa, is everything okay with your computer? That's becoming a little distracting to people. Please put your hands down. Go ahead, Colin.
Because the pattern continued through all of the even tens that were in that were within 100,
Right, so let's think, if we continue to count by 100, count by fours, what comes after 100?
4.
100.
104.
And this still is an even number in the tens place. And look at that, we still have a 4 there. What comes after 104, Colin?
108.
Even number in the tens place. And what do we have in the ones place?
8.
And that continues with our pattern. Very good. Okay, we got one more. Who hasn't got to do one today that's dying to answer letter D? Okay, Peyton, I see your hand first. You're going to tell them we're going to circle the multiples of 9. So I'm going to go back up to my grid and you're going to tell me the multiples of 9 and I'm going to circle them. Whenever you're ready.
Oh yeah, we plug in my headphones. Okay.
All right.
9, 18, 27, 36, 45, 54, 63, 72, 81, 90, and 99.
Very good. I almost thought I was going to get a bingo at first or something. We were going the whole way back. Wow, that's pretty neat. Okay, so Peyton, you help me circle all the multiples of 9. I want you to choose one of those numbers that we circled. Don't pick 9 though.
63.
Okay, so down here it says choose one of those. Peyton chose 63. We need to find the sum of the digits. So if we're finding the sum, Peyton, what operation are we switching to?
Addition.
Okay, so what is 6 plus 3?
9.
Okay, pick another one of the numbers that we circled.
45.
All right, now what's 4 plus 5?
9.
What do you notice about the sum of these digits?
They all equal 9.
They do. And so, but like, I'm looking just down this list because I find this pretty interesting. Numbers are crazy. So if you add up all of these that went in the diagonal, they all equal 9. Even right here, it's not until you get above 90 that they don't. Miss Jameson, can you think of any reason why that it's like that?
I don't know the reason for it.
All of these equal 9 except for 99. So I'm going to put they all equal 9, but let's just put in there except for 99. It's the only
Maybe
one.
I was going to say maybe it's just when single digits are factors, but that's not true because 90 works and that's a 9 times 10.
Yeah. It's pretty neat though. I think they just want to, yeah, Colin, do you think you know why?
I was just gonna say, I know a division strategy where any number that's divisible by 9 has to add up to a number divisible by 9. So 6 and 3, 4 and 5, they add up to 9. And 99, 9 plus 9 adds up to 18.
Yep, so they're all divisible by 9. Colin, you should ask Mrs. Jones to give you the sieve of, it's a really big name. Miss James, do you remember? It's like it's SIEVE. Do you remember that? It used to be one of the challenge things that we all did in 4th grade. And it's not in this program. It's called like the sieve of Aristotle or Aristocrates, or it's this crazy long name. And it has something to do with when you're looking at a chart, like how the numbers fall in there. So if you're looking for something to do one day with her, you should have her give you that problem, because I know she has copies of it.
Miss Shevchik,
Uh-huh.
it's kind of the same with multiplication too. As if you multiply 9 times 9, it equals 81. 8 plus 1 equals 99. I mean, not 99, but 9.
Okay. Good. Nines are crazy, especially when you can do the nines trick with the multiplication. Okay, so today we did a lot with multiples, and if you notice, we're still talking about factors too. So where we're moving on to is we're going to be starting division, and that's why we've been really pounding your facts, because you're really going to need to know those. So if you're in our Zoom right now, you don't have to send me these pages, but everyone still has something to do after this Zoom. What do you need to do and submit today? Tyler?
10 minutes of extra math.
Before that.
Your lesson exit
There
ticket.
you go. Very good. It's right here. Lesson 24 exit ticket. If your packet's in school, what can you do to be a problem solver and not just give up because you don't have your paper? Nolan?
Use a blank sheet of paper.
Pull it up on your computer so you can see it. Work it out on a blank piece of paper. That's where you can do all your thinking, all your problem solving. Then just hop on the computer and submit it. And then tomorrow, remember, tomorrow's the day where you're going to get on maths on your Mathsology page, and you're going to need your mid-module assessment from last week. And there's a video on there, and I go over every single question. And then if you, after you watch the video, if there's things that you're confused about, you're going to send me a message, and we're going to make some times. I'm going to put you guys into some groups. If I have a pocket of people who really still don't understand number 3, I'm going to give it a certain time, because it's a pretty long test. So everyone's not going to meet for all of them. If you see your mistakes and you don't feel like you need any further explanation, then you don't have to message me which problems that you need more help with.